looking at derivation of the continuity equation for rectangular block. Now let's consider this block as our rectangular block. If you look at this block critically, we see that this block has 3 dimensions. We have this one, we have this one coming this one, we have this one coming this. So if you bring these 3 dimensions out, you are going to have this particular coordinate system, which has the x, y, and z. Continuity equation is derived from the conservation of mass, which state that mass can neither be created nor destroyed, but can be transferred from one point to another. In fluid mechanics, the continuity equation that is gotten from the conservation of mass is described as the mass accumulated inside a block is equal to the mass that flows in the block minus the mass that flows out of the block at a given time, what? Delta T. Now, what is the formula for the mass flows in? The mass flows in, let's know the mass flows in as what? As F, right? Let's know the mass flows in as F, which becomes the mass flow in. Then let's describe the area of the block as A. This becomes your what? Area. Then let's describe the volume of the block as V, which is equal to what? Volume. Is equal to volume. Now, if we are to consider the mass of fluid that flows into this block in the x direction, we can simply say that, okay, the mass of fluid that flows in this direction becomes f of x, which becomes the mass of fluid that flows in the x direction at this particular what? Coordinate x here. Considering this distance x flows in, and the mass that flows out in the x direction becomes the mass that flows out of the block in the x direction, which is the same. Remember that is fx that flows in, so it's the same fx that what? That flows out. So which is fx subscript x now, but now remember that this point here, this distance here is what? Is x. So what will be the distance from here to here? So if I have to consider the distance from here to here, it will now give us x plus delta x. Now the mass that flows in the x direction becomes mass in x direction becomes what? F subscript x will be equal to, remember that we are considering the x direction. Now, what is the formula for mass flows in? We said that the mass flow in is equal to F multiplied by the what? Area times what? Delta T. If that is the case, we can simply say that the mass that flows in the x direction becomes f of x, which simplifies the mass in the x direction, multiplied by the what? The area in the x direction and what? Delta T. So what will be the area in the x direction? The area in the x direction, remember that we are considering what? That the ones that flows in this way. All right, the ones that flows in this way. If you look at our coordinate system, we said that the one that comes like this, is for f of y. Then the ones that comes down, that flows downward, is for f of z. All right. Now, if we are to consider the distance, remember, if this one here is x now, what will be the distance from here to here? The distance of the block from here to here becomes delta z. The distance of the block from here to here becomes delta x. the distance of the block from here to here, which is the same thing as from here to here, becomes what? Delta y. So if we are to consider the area in the x direction, that means since it's going the x direction, we have to consider this particular one here times this. Remember, I will consider the x direction. So the area becomes delta z times delta y. So if that is the case, our ax here becomes delta z delta y at a given time t. This change in t means that, remember they say mass flow in at time what? Delta t. So it becomes what? Mass flows in at delta t. So this becomes the mass that flows in the x direction. The next step now is to get the mass that flows in the y direction. So this will be mass in y direction. How do you get the mass in the y direction? The same thing. Remember, the y direction is this way. Since it is flowing this way, remember, this becomes the what? The y coordinate. So at y, the initial point is always y. Now, if this is going this way now, it will come out from this point here, where we are now going to have the mass that flows out becomes this, y plus delta y. Remember, the beginning distance is y, then from here to here will give us y plus what? Change in y. So our mass flows in for y becomes this one here, which is this. So this will give us F at y. Fy is equal to F of y multiplied by what? Ay times what? Delta t. This will give us F of y. Now, what is our Ay? Remember, since we are considering just the y direction, this one here becomes what? 0, and our area now becomes delta z times what? Delta x. So our Ay becomes delta z delta what? X, considering time what? Change in t. So this becomes the mass flow in. This becomes the mass that flows in the y direction. Mass that flows in x direction. Next step now is to get the mass that flows in z direction. Mass in z direction. In z direction now, our mass that flows in becomes F of what? Z subscript z. We've already written it here. Remember, it's coming downward. So this for the z is coming downward. Remember, subscript z. So since it's coming downward, it will come out from where? From this point here. It will come out from this point, which is now going to give us F of z at what? Now, it's coming from here to here. It's coming from here to here. So the distance becomes F of z plus change in what? Z. So if we are to consider that, this will give us F of z at z times what? Times az multiplied by delta t. So this will give us F at z. Now, what is our az? Since we are considering the z direction, this one here becomes 0. Our area now becomes delta y and what? Delta x. So this becomes delta y delta x, considering the time v and delta t. So this becomes the mass that flows in the z direction. This becomes the mass that flows in the z direction. Done with the mass flows in the 3 dimension, x, y, and z. The next step now is to consider what? The mass that flows at time what? Delta t from the block. Now, if you look at the block, we said that this one that flows in, this one that flows out. In the x direction, mass flows out. mass out in x direction, mass out in x direction becomes, remember x direction is this way, so the ones that comes out becomes what? F of what? X. What is this thing here? Becomes x plus delta x, which is equal to x plus delta x. The area we consider for x is also the s is equal to the y, the z. We are considering time what? Delta t. The same concept is applied for mass out in y direction. Mass out in y direction is the same thing as f of y plus delta y. Remember, for y, we are considering this one. So it flows out from here. We have the ones that flows out is fy, y plus delta y. Then the area now becomes, this one becomes 0. It becomes delta z, delta x. Here will be equal to delta z, delta x times what? T. The next step is to get the mass out. Mass out in z direction. Mass out in z direction is also the same concept. F of z at z plus delta z will be equal to, now z is flowing in from here, so the ones that flows out becomes this, is equal to f of z at z plus delta z multiplied by the area. What is the area here now? Remember, since we are considering z direction, this becomes 0, this becomes 1. Then the area becomes y and x. So this becomes x, y. Remember, we are considering at a time delta t, so this becomes delta t. Now we have the mass that flows in and the mass that what? Flows out. Let's total all the mass that flows in. So the total mass flows in, total mass flow in will be equal to, we said that for x axis, it is equal to f of x at x multiplied by the area y, z, and the time. This one now is just for the x, then plus f of y, y multiplied by the area, which is z and x times delta t, plus, consider the coordinate of z, it becomes f of z, z times the area, delta x, delta y at time what? At time t. We have this. So let's call this our equation 1. The same thing, let's total all the mass that flows out. So we can simply say that total mass out will be equal to f of x, which is f of x at x plus delta x, then delta y, delta z, delta what? T, plus, let's consider the y direction. It becomes okay, this will be equal to, it becomes f of y, y plus delta y, delta x, delta z, delta t, plus mass in z direction, which becomes f z, z plus delta z, dx, delta y, delta t. Let's call this our equation 2. Now, if you look at this now, we now have the mass in at time t, which is this one here, and we also have the mass at time t, which is this one. The one that's remaining for us now is to get the mass that is what? Accumulated inside the block. Accumulated inside the block is given as Cp t plus delta t minus Cp at t. Then multiply by the volume of the block. In this case now, since our block has 3 sides, the volume of this particular rectangular block will be equal to delta x, delta y, and delta z. So this becomes the volume. So if we substitute this volume in place of this volume, our mass accumulated, MA, let's use MA to represent mass accumulated, will be equal to Cp t plus delta t minus Cp at t. Remember, I said V here is volume. So if we multiply by volume, instead of writing volume, you can still say that multiply by delta S, delta Y, and delta Z. So this becomes delta X, delta Y, delta Z. So we have this. This becomes what? The mass accumulated inside the block. Let's call this equation 3. Now the next step now is to substitute equation 1, equation 2, and equation 3 inside what? This particular equation. Substitute equation 1, equation 2, and equation 3 inside this particular equation. Equation 2 and equation 3, we said that equation 1, which is mass flow in, is equal to f of x at x, delta y, delta z, delta t, plus f of y, delta x, delta z, and delta t, plus f of z, delta x, delta y, and delta what? T. Remember, we said that this is our equation 1. Also, our equation 2 is mass flow out is equal to f of x, x plus delta x, delta y, delta z, and what? Delta t, plus f of y plus delta y, delta x, delta z, delta t, plus f of z plus delta z, delta x, delta y, delta t. This is our equation 2. Now remember that we said that this is our equation 2, but if you are considering the flow rate of the masses inside the block, the mass that flow out of the block becomes this particular equation plus the flow rate multiplied by the volume, delta x, delta y, and delta what? Z at a time t. So if we are considering the flow rate, this becomes this. So this becomes our equation. This becomes our equation 2. Remember that the one that we considered the first time, there was no flow rate, but now the mass flow out of the block becomes this equation with flow rate, since we are considering the flow rate of the mass inside. So we have this. Our mass accumulated will be equal to, we said that is equal to Cp at t plus delta t minus Cp at t multiplied by the volume delta x, delta y, and what? Delta z. So that this is our equation 3. So what was our equation star? We said our equation star was mass accumulated is equal to mass in minus mass out. Minus mass out. So if we are to substitute the equation of mass accumulated, the equation of mass in, and equation of mass out into this particular equation 3, remember we said mass accumulated is equal to mass in minus mass out. So our mass accumulated is our equation 3, which we have Cp t plus delta t minus Cp at t multiplied by the x, the y, and what? The z. So this is equal to our mass accumulated is equal to mass in. What is our mass in? Mass in is f of x at s, the x, the y, the t, the z, the y, dt plus f of y, y, the x, the z, dt plus f of z, the y, the x, dt. Now everything here is the mass in. Next step is minus, that is minus the mass out. Our mass out is our equation 2, which we have f of x, x plus delta x. We have dy, dz, dt plus f of y, y plus delta y, dx, dz, dt plus f of z, z plus dz. We have dx, dy, dt. Then we now have plus q times delta x, delta y, and what? Delta z, delta t. Now we have this. Now from here to here becomes our mass flow out. So if this is our mass flow out, the next step now is to divide through by the coefficient of q, which is the x, the y, the z, and the t. Divide through by the x, the y, the z, the t. So if we divide through by this, in this particular case, if delta x, delta y, and delta z, if the x, the y, and the z, the t divided by this particular mass accumulated, the x will cancel the x, the y will cancel the y, the z will cancel the z. We'll be left with Cp at t plus delta t minus Cp at t. Everything here now divided by what? Delta t. Now it's divided by delta t because this one will cancel this one, this will cancel this, and this will cancel this. Also, divide the individual parameter by this. We are still going to have, for this first one, the z will cancel the z, the y will cancel the y, the t will cancel the z, the the t, will be left with f of x at x divided by delta x plus the same concept here, delta s cancel delta x, delta z cancel delta z, delta t cancel delta t, will be left with plus f of y divided by dy. And also, we are done with this, plus for this next one, delta x cancel delta x, delta y will cancel delta y, delta t will cancel delta t, will be left with plus f of z divided by delta z. Then minus, if we use the minus to open this bracket, this will give us minus this first one here will be minus delta x is not there, delta y now we cancel delta y, delta z we cancel delta z, and delta t we cancel delta t, so we'll be left with a minus f of x plus delta x all divided by delta x, then minus times plus will give us minus f of y plus delta x plus delta y. Delta x will cancel delta x, delta z will cancel delta z, delta t will cancel delta t. So to be divided by delta y minus plus will give us minus f of z at z plus delta z. Delta x will cancel delta x, delta y will cancel delta y, delta t will cancel delta t. So here we'll be left divided by what? Delta z. Then plus q. Remember, we divided by delta x, delta y, delta z, and delta t. So everything here will cancel everything here except the q. So we'll be left with minus plus will give us minus q. So if we divide this equation by delta x, delta y, delta z, and delta t, we are going to have this particular equation. So since we have this, the next step now is to collect like terms. Okay, so after dividing by delta x, delta y, delta z, and delta t, the next step now is to collect like terms. So if we are to collect like terms, we are going to have this Cp t plus delta t minus Cp t. This will be equal to the ones for the x coordinate, take them at one side. So this becomes f of x at x. Then this one here, this is the one, this one has x, and this one also has x. So it becomes minus f of x at x plus delta x. Now everything here, remember this one divided by delta s, this divided by delta s, so everything divided by delta x. Then also we go for y, this becomes plus f of y at y minus f of y at y plus delta y divided by, this is divided by delta y, this is divided by delta y, so this becomes delta y. Plus, the next step is to go for z, so it becomes f of z at z minus f of z at z plus delta z divided by, if you look at this is divided by delta z, this is divided by delta z, so this becomes delta Z minus what? Q. So after collecting like terms, like terms, the next step now is to take limit. Limit this one to 0, limit this to 0, limit this to 0, and limit, okay. Remember we divided by delta t, so this is supposed to be divided by delta t. So if we limit everything to 0, limit this to 0, limit this to 0, limit this to 0, and limit this to 0, we are going to have lim delta t, delta y, and delta z, delta t tends to 0 of this equation. If we limit these parameters to 0 in this particular equation, this becomes partial Cp divided by partial t, which will be equal to, limit delta s to 0 here, everything here becomes partial f of x divided by partial x, then plus, okay, remember this is, so here is minus. Limit everything here to 0, we are going to have minus partial fy divided by partial y. Limit everything here to 0, we are going to have minus partial fz divided by partial z, then minus q. So therefore, this equation here becomes the continuity equation for a rectangular block. Thank you. Boy, finally.